Hello everyone, welcome back to 7-day machine learning challenge on Bytes of CSE on interview question, and we are on day 3, and the question of the day is what are some categories of outlier detection approaches. So there are many categories to that, so we are going to be discussing quite a number of them. So first we'll talk about the statistical methods. And the first test we have is the Z score, like how many standard deviation away is a point from mean. And if it is greater than 3, then that point is an outlier. Similar to Z score, we have modified Z score where we measure how many standard deviation away is a point from the median. So here also the greater than 3 rule applies, and if your data contains a lot of outlier, then it is always better to use a modified z-score than a z-score. And then you have Tucky's fences, where there's a rule like Q1 minus 1.5 IQR and Q3 plus 1.5 times IQR are your points which can be flagged as outliers. So what is this? Basically, we divide the data into 4 equal parts based on the values and their distribution, and that gives rise to 3/4 of your data. This is quarter 1, this is quarter 2, and this is quarter 3. So your quarter 1, the range that is quarter 1 minus quarter 3, gives the interquartile range, which is this IQR. So if, sorry, I think, sorry, this was the point. So this is quarter 1 and this is quarter 4. I'm sorry, I just made one mistake. This was the starting point. Anyways, so if there is any data point which is 1.5 times interquartile range away from this quarter 1, that is less than quarter 1, and if it falls 1.5 times interquartile range above this last quarter, that is quarter 3, then that point becomes an outlier. Then we have some not so popularly used tests like Grubbs test, which detects single outlier at a time. It works on univariate data and it calculates the largest absolute deviation of the sample mean in units of sample standard deviation. So this is your sample mean, and this is a sample to be tested. And basically it as you can see, the point, the value, like only one point can be detected at a time because you're taking the max of this distance. So it takes quite a number of iterations to uncover all the outliers. So this is basically, it can be used when there is only 1 or 2 outliers in your data. So it's not very popularly used test. Next, you have a chi-squared test. So basically, we use a modified version of chi-squared test to detect an outlier in multivariate data. So here is a mathematical equation for it, where O is the object to be tested. OI is the value in the ith dimension. EI is the mean on the ith dimension among all objects. And if this value is greater than some threshold, then that becomes an outlier. Again, this is also not very popularly used. Then we have some distance-based methods like k nearest neighbor, where points with large distances from its k nearest neighbor is a potential outlier. Where am I? Okay. The k nearest neighbor. Next, we have distance from centroid. So there is a central data, and from here a centroid, and from there the distance is measured from between all the data points, and the points with large distances again can be an outlier. Then we have Moholy-Nagy distance, which basically is a metric that finds distance between a point and the distribution. So it calculates the distance between the point and distribution by considering like how many standard deviation away are 2 points from each other. For example, suppose like the distance between P1 and P2, according to Moholy-Nagy distance will be like how many standard deviation away is P1 from P2. Then if your data is in like there are some density based methods like local outlier factor, which measures the local density deviation of data point and it assigns a score, and the points which have a low local outlier factor score is flagged as an outlier. Then you have db scan, where you just group the points into clusters, and this is based on density, and outliers are the data which won't belong to any of the clusters. And then you have like isolation forest, where data points, there are partitions which are used to isolate a data point from its neighbors or from the other data points. So since outlier is going to be in some boundary, so it won't need a lot of partitions to be separated from the main data set. So the points which needs fewer partitions to isolate will be your potential outlier. Then you have some clustering based methods. So when your data is in clusters, in fact dbscan is also a clustering based approach. So here the important ones are k-means clustering, like data points with large distance from cluster centroid will be an outlier. Then you have Gaussian mixture model, where a number of your Gaussian distribution or normal distribution will be applied to the data set, and the points will fit any of these or multiple of these distributions, and outliers will be those points which will have which will barely fit any of these distributions, so it will have a low likelihood of belonging to any of these normal distributions, and that way you just find out that this is an outlier. Next, you have some machine learning based methods like autoencoders, where a neural network is trained to find the pattern in your data, and this learns the data and it replicates your data set. So there will be some error because, of course, it will not totally understand the distribution, but the points which are outliers, for those points, there will be a high error, which is also known as a reconstruction error. I'm just not finding the pen. Okay. This will have a high reconstruction error, and that is because the points will deviate from the general pattern. So those points will be your potential outlier. Then you have one class SVM, which trains a boundary around the normal class in a high dimensional space, and the points which are outside this boundary is your outlier. Then you have some model based methods like hidden Markov model, which models the sequence pattern, and the points which deviate from the expected sequence becomes an outlier. Then you have Bayesian network model, which is a graphical model that represents a probabilistic relationship between variables, and the observations which have a low likelihood will be your outlier. Then you have some time series based methods for your time series data. For example, moving average or the rolling average, and points that will deviate significantly from the rolling or the moving average becomes an outlier. And then you have seasonal decomposition, where this is basically a statistical method that breaks down data into three components, which is your trend, seasonality, and residuals. Here you have. And trend is basically a long-term pattern which shows the direction in which the data moves. Seasonality, which is a cyclic pattern that occurs within a fixed time period, like it can be quarterly, bi-monthly, annually, half yearly, like that. And residual is what remains, like the data that does not exactly fall on the category of trend or seasonality. So any data which deviates from any of these, like these three, will be your outlier. And finally, you have LSTM, which is a type of recurrent neural network which learns sequence pattern, and the points that do not adhere to that sequence will be flagged as outlier. And this is basically whatever I have discussed so far with you. So, the categories and the techniques, and what are the distributions for which it is suitable. This is all given in this table. You can take a screenshot of this table. And now, as per the final answer, I would highly recommend you to frame your own answer, because see, there are so many methods, and of course, in an interview, you will not be expected, and you can't really like blurt out an entire epic of how this outlier detection happens and so on. So, this is just one way of answering the question, but I would really recommend you to frame your own answer. So there are a number of ways to detect outliers, and based on data distribution, we can use them. Like if the data is normally distributed, statistical methods like z-score, modified z-score, Tucky's fence rules can be applied. If our data is high dimensional and continuous, then k nearest neighbor can be applied. But if the data is complex, then it would be better to use autoencoders or isolation forest. For time series data, we can use seasonal average. Then we also have clustering based methods like k-means or db-scan for clustered data. So now, something that I would recommend you to go through is, just a moment, I'm just not finding the pen today. Okay, this, here it is. Okay, so this is your personal touch to the answer. So I personally prefer to use blocks plot to detect them. In fact, by inspecting the output of df.describe method by the Pandas library, that gives us information on mean, standard deviation, and the values of the quarters for numerical data, we can make a quick guess by looking at the max and mean values, that if the column contains potential outliers. So this basically showcases that you have already had some experiences, or you know the basic data inspection techniques of your machine learning data set. So I would highly recommend you to give a personal touch. So this is one way. So box plots, violin plots, these are actually used to detect outliers in your data. And df.describe, if you work with it, you know, like it gives you a plethora of information, and based on Tucky's rules and z-score or modified z-score, you can actually make a guess, a very educated and calculated guess, that if a particular data column contains outliers. So that is all for today, and stay tuned for day 4. Thank you for watching.